Hey guys, it's Mr. Intunza, Mr. McCaffrey with you. Say hi, Mr. McCaffrey.
Yo, 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 yo.
Hey, sounds like Yogi Bear. But this is what we're going to be doing is we're going to be doing your first exams test corrections. So you guys all have your exams. So all you need to do is go through these videos, look at your mistakes, fix them, understand what you did wrong. And if you still there's some things that you're kind of iffy about, then come see us. Okay, so here we go. Let's go through these problems. The very first problem in your exam was they give you the following sequence or equation, and then they want you to find the first 5 terms. Well, to find the first 5 terms, all we have to do is, well, let's see, we want the first term, we're going to take n and replace it with 1. Okay, now, once you have the first term, then you can do several ways to do it. You can keep using the formula, or you can try to use the common difference. Whichever way is going to work, so here we go. So I want to know what a sub 1 is, which means that n is the first term, so n is 1. So we get negative 8 times 1 plus 5. Well, negative 8 times 1 is negative 8, plus 5 will give you a negative 3. So there's your first term. Well, if I want the second term, we do the exact same thing, but the second term. So we want a sub 2, which means I want my second term in the sequence. So we plug in a 2 for n. So here we go. Negative 8 times 2 plus 5. And we know that negative 8 times 2 is negative 16 plus a positive 5. Remember, a negative and a positive, so you really subtract, keep the sign of the highest absolute value. So it's going to be negative 11. Now, a sub 3, do the same thing. Negative 8 times 2 plus 5, which gives you negative 8 times 2 is negative 16. Oh, wait, sorry about that. It's not a 2, it's actually a 3 because we want the third term. My bad. So negative 8 times 3 is negative 24 plus 5 is negative 19. 19, right? So a sub 4. Now we're going to plug in a 4. So negative 8 times 4 plus 5 equals 4 times 8, or negative 8 times 4 is negative 32, right? Plus 5 is going to give us a negative 27, I believe. Yep. Right? And the last one, a sub 5, is negative 8 times 5 plus 5. And it's going to give me negative 8 times 5, negative 40, plus 5, negative 35. This is one of the ways you could do it. And there's the first part. Second part says, find the 67th term. Well, this is as complex as it sounds. You're like, 67 terms? You want me to do this for 67 times? No, we don't want you to do that. Could you do that? You could. Is that the best way to do it? Probably not. Let me show you. Since they already gave you the formula, all you need to do is just plug in your 67 in for n, and you're done. So here we go. I want to know my 67th term of this specific sequence. Okay. Oh, look at that. So all you got to do then is just simply plug in a 67 here, right? Because this means this formula gives you any term you want. Well, if I want this one, that means I replace n with 67. So let's plug it in and see what we get. So I'm going to get my handy dandy calculator, and we get negative 8 times positive 67, and third gives you a negative 536 plus 5, and it gives me a negative 531. This is my 67th term. There it is. Okay. Now, if we move over here, we have describe the type of sequence. Well, if you notice right here that we have negative 3, negative 3, negative 11, negative 19, negative 27, negative 35. So there's 2 types of sequence. It's either geometric or arithmetic. Now, so remember, to check if it's geometric, you divide the second term by the first term, the third by the second, and so on and so forth. And if it gives you the same number, then you know that that is a common ratio, so it's geometric. However, it could also be arithmetic or arithmetic, which means that you will subtract the second from the first, the third from the second, and if it gives you the same number, which is called the common difference, then you know it's arithmetic or arithmetic, right? So let's see. Negative 11 minus negative 3 gives me a negative 8. Okay, so the difference is negative 8. Let me try these two and see what it is. Negative 19 minus negative 11, and it gives, oh, look at that. This gives me a negative 8, that gives me a negative 8, the difference. Therefore, I know this must be an arithmetic sequence. So you will say this is an arithmetic sequence. And then you're going to say, well, why? You have to tell me why. Well, it's an arithmetic sequence because it has a common difference, right? Because a common difference, that's an F, difference of negative 8. And that's the answer for that. That's all you got to say. Simple as that. Or if you want to put arithmetic sequence because d equals negative 8, I know exactly what you're talking about. Okay, so no problem. Present the sum of the first 50 terms in the summation notation. Okay, remember summation notation is just a fancy word for your big Greek letter, sigma, right? So there it is. There's my sigma. So the first 50 terms, now it just says to represent, which means it just wants me to set it up. That's it, right? The first 50 terms. Well, if you recall in the beginning of the problem, we started with a sub 1, which was my first term, right? So I'm going to say, you know what? I'm starting from my first term, and I want the first 50. So my lower limit is 1. My index is n, right? So this is 1. So my upper limit, first 50. So if I'm starting with 1, well, what are my first 50 terms? Well, I want from 1 to 50, right? Okay? All right. And it says summation notation, which means, okay, what am I going to be using here? Well, they actually gave it to you already, so you don't have to actually find it. It's there. They said that, remember your equation was a sub n equals negative 8n plus 5. So boom, there it is. This is the representation in summation notation of the first 50 terms of this sequence. Notice this says, you know what? Take this sequence, plug in the number 1, then plug in 2, plug in 3, 4, 5, 6, 7, all the way up till you get to 50 and add them all up. That's what this is telling you. So this is what we wanted you to do on this one. Okay? Summation notation, make sure your lower limit, your upper limit is there, and your equation. Okay? And that's it. And now, if we go over here to part 5, it says find the sum. Now, basically you're going to do exactly what this problem is asking you to do. So on this one, I just want you to represent it. On this one, I want you to actually do it now. And you all know this formula because it's in your package, which says the sum of whatever terms you're looking for, the sum of whichever terms is equal to the number of terms you're talking about over 2 times your first term plus your last term. Okay? So let's plug in what we have and see what we come up with. So I want the sum of the first 50 terms, right? Equals n, which was 50, your number of terms, over 2, times a sub 1. Well, a sub 1 is actually negative 3. We know that. Plus my last term, which in this case, if I want the first 50 terms, my last term is the 50th term. But there's a problem here. Do I know the 50th term? Not at the moment. So guess what we're going to have to do? We're going to have to find it. Once we find it, we can plug it in here. Well, if you guys will follow me over here, and I'll show you just how to do that. Recall that we found the 67th term. Remember the procedure we used? Well, guess what? If I want to know the 50th term, we do the exact same thing, except that I don't want the 67th term. I want the 50th term. So instead of 67, I'm going to plug in a 50. And whatever that is, that's what I'm going to use in my formula over there. So let's find it right here. So a sub 50 equals, let's see, negative 8 times n. But in this case, n is 50 because I want the 50. What is the 50th term? Plus 5. So all we do, we multiply this. Negative 8 times 50 gives you a negative 400 plus 5 gives you negative 395. So this is my 50th term. So now all I'm going to do is take this number, plug it in my formula, do it all on the calculator, and we're done. So follow me over here, guys. So we said this was 395. See? Now we have everything we need. The number of terms, the first 50, right? Divided by 2. This is just part of the formula. This is just the formula, that 2. Times my first term plus my last term. Or the term, this is your last term, the 50th term. This is the 50th term. Now, we're just going to apply this formula, and it's going to add all the numbers on that sequence. Starting with 1, all the way until 50, and then it's going to add them all up. Okay, so here we go. So we get negative 3 plus negative 395. That gives you negative 398. This is negative 398. And then we're going to multiply by that. 50 divided by 2. Well, I know that. If you take 50 cents, divide it among two people, you each get a quarter. So you get 25. So the sum of the first 50 terms, simplify to that. So let me just multiply by 25. And my answer is negative 9,950. So my friends, this right here is the sum of the first 50 terms of that specific sequence. And there it is. There's number one, guys.